Hello everyone, today let us discuss about AC voltage applied to a capacitor. We have already seen AC voltage applied to a resistor and AC voltage applied to an inductor. For all the circuits, I already told you 5 points are common, that is voltage equation, second is current equation, and the third is resistance of the circuit, or it is also called as reactance, or it is also called as impedance for LCR and LRCR circuits. And number 4 is phase difference between voltage and current. And number 5 is power of the circuit. And coming to the figures, 3 figures are compulsory for every circuit. Number 1 is circuit diagram, number 2 is wave diagram, and number 3 is phasor diagram. So these 8 points are common to every circuit. So let us start our discussion by drawing a circuit diagram. So the circuit diagram goes like this. It is simple. Take AC voltage applied to a capacitor. That's all. And here we write V, that is Vm sine omega t, and here is capacitor. So the voltage equation V is equal to Vm sine omega t. Let it be equation number 1. And then we will go for the other equations. We all know the relationship between voltage capacitor and a charge from our second chapter, that is Q is equal to CV. We all know very well, and therefore V is equal to Q divided by C. Let it be equation number 2. Therefore, let us equate both these equations because both of them represent voltage, that is LHS. Left hand side of the equation represent V and V. Therefore, we can equate both of them. As you equate both of them, you will get now, that is Q by C is equal to Vm sine omega t, or Q is equal to C Vm sine omega t. So this is the next equation what we got. Now we know from our previous discussion, that is from the third chapter, we all know very well, that is I is equal to, you know very well, I is equal to dq by dt. Therefore you can differentiate this equation, which is equation number 3, and you can differentiate both the sides with respect to the time. Therefore you will get current I is equal to dq divided by dt, that is Q means this one, that is CVm sine omega t from our equation 3. So you can write d by dt of CVm sine omega t. Whereas C is a constant which you cannot differentiate, take it out. C into, and Vm also a constant, take it out, you cannot differentiate. C Vm d by dt of sine omega t. So you have to differentiate it now. So once you differentiate, you will get the current equation, that is I is equal to CVm d by dt of sine omega t. Like you know from our trigonometry, that is d by dx of sine x is equal to cos x. You know that. In the same way here you will get now, that is d by dt of sine omega t is cos omega t, and also you will get extra d by dt of omega t again, that will become C Vm cos omega t into omega. So you can write it as omega C Vm cos omega t. This is the current which we got. Okay, so you can also write it as, that is I is equal to omega C and Vm cos omega t. You can also write as a sine 90 plus omega t, because sine 90 plus theta is cos theta. You know very well, no? Trigonometry, sine 90 plus theta is equal to cos theta. That I have used here. Then after that, if you see this first part, that is omega c, it is multiplying Vm. Now I will take it down so that we will have a round figure like Ohm's law. So let us take it down. I is equal to Vm divided by 1 by omega c. So once it comes up again, it becomes omega c Vm. Nothing is wrong in writing like that. And we will write it as omega t plus 90. Okay. So then what is the next thing? The next thing is I is equal to Vm divided by 1 by omega c. You can write it as sine omega t plus pi by 2. Now, if you see this part of the equation, which I am keeping in red color square bracket, so that you compare with Ohm's law, that is V is equal to, you know very well the Ohm's law, V is equal to IR, therefore I is equal to V by R, that is the Ohm's law. Now, if this second part of the equation, what is the maximum value for that? The maximum value of sine function is always 1. So when sine function is 1, Im, that is the peak value of current, Im is equal to Vm divided by 1 by omega c. Compare this with Ohm's law. In place of I, you have Im. In place of V, you have Vm. And in place of R, you have 1 by omega c. Therefore, in place of resistance, we have 1 by omega c. That is called as the reactance. Reactance. So, reactance is nothing but here, which is equal to 1 by omega c. Because it is a capacitive circuit, we write it as capacitive reactance. Capacitive reactance is equal to 1 by omega c. That is, X is the symbol of reactance. Xc is equal to 1 by omega c. We got the resistance or reactance of the circuit. Now let's go back to our current equation, because we need to write the current equation substituting this. So this is our current equation. So let us take it as equation number 4, because already we have given here equation 3. So there we will take it as equation 4. So this equation I am taking it as equation number 4, and the next one what we got now, reactance, that we will take as equation 5. Now substituting equation 5 in equation 4, we get, so let's go back to our equation 4. This is Vm by 1 by omega c. So in place of 1 by omega c, I will write Xc. Therefore, we will get the equation of the current as follows. That is, therefore, let us substitute equation 5 in equation 4. Then we get I is equal to Vm by Xc into sine omega t plus pi by 2. But let us take this as the maximum value of current, that is Im is equal to Vm by Xc. Therefore, you will get I is equal to Vm by Xc, means in place of that now I am writing Im. Therefore, you will get Im sine omega t plus pi by 2. This is the equation of the current. Let it be equation number 6. Now we got voltage equation, we got current equation, we got resistance of the circuit, that is the reactance. Xc is equal to 1 by omega c. And what else we need to know now? We need to know the phase difference and we need to know the power. So let's take the phase difference. let us compare these two equations. That is V is equal to Vm sine omega t. That is the voltage equation. I is equal to Im sine omega t plus pi by 2. Now very clearly you can see here, this is the phase difference, that is pi by 2. That is also plus pi by 2. Plus pi by 2 means what? Current is leading the voltage by 90 degrees. So what we can write now? Current is leading the voltage by pi by 2. So the phase difference is now, the phase difference is pi by 2. So we got finally that equation also. Let it be equation number 7. Now we got phase difference also. What else is remaining? We have only one thing remaining, that is power of the circuit. So let's go for the power of the circuit like how we have done in the case of inductance. Let us proceed in the same way. Now let's go for the power. Power is equal to, that is V into I. Okay, so let us write the values of V and I. That is Vm sine omega t. I means Im sine omega t plus pi by 2. Im sine omega t plus pi by 2. Okay, therefore we can also write it as Vm Im then sine omega t. Sine 90 plus theta is cos theta. So you can write it as a cos omega t. Okay, then multiply by 2 divided by 2. Then we will get now, the next equation will be, that is equal to Vm Im by 2 sine omega t cos omega t. So you can keep it in the bracket, and you know from trigonometry very well, 2 sine theta cos theta is equal to sine 2 theta. You know this, substituting, that is here using that formula, Vm Im divided by 2, this will become sine 2 omega t. This is the power. Now average power means what? You keep bar on the top, you put it in the triangular bracket. So once you keep it in the triangular bracket, you will get now, that is, once you keep it in the triangular bracket, you will get Vm Im by 2. You need not take average, take it out. Vm Im by 2 within triangular bracket sine 2 omega t. This is a function of sine function. So this is a function of sine, that is, it is a sine function. So average of sine function over a full cycle, it becomes 0, because one full cycle means this and this. So one full cycle, if you take an average, that is average of positive cycle and negative cycle, this value will become 0. This particular value becomes 0. Therefore, power you will get now, P bar is equal to Vm Im divided by 2 into 0. Therefore, power is equal to, that is P bar is equal to 0. So power of the circuit is equal to 0. So let it be equation number 8, because already we have taken here as equation 7. So let it be equation number 8. So we got all the 5 points now. Okay, we got all the 5 points. Voltage equation, that is Vm sin omega t. Current equation, Im sin omega t plus pi by 2. And then reactance of the circuit, Xc, which is equal to 1 by omega c. And then phase difference between voltage and current, that is equal to pi by 2. Whereas current is leading. And the last one is power. Power is equal to 0. Here, I already told you in my first video of AC circuits, you have to make a tabular form. At the end of every circuit discussion, you have to fill the form. You can go to my video on resistance circuit. you can go through that, and I have mentioned there the table. Fill the table, you will by heart them, and it will be easy for you. Now after that, what else is remaining now? We need to draw the wave diagram and we need to draw the phasor diagram. That is the only thing left now. Let us go for first wave diagram. And always the voltage shape will not change, it will be in the same position. V is equal to Vm sine omega t. That will not change. But now let's see the current. Current, if you see now, current equation we know. So voltage equation you know, V is equal to Vm sine omega t. But now current I is equal to Im sine omega t plus pi by 2. So this is the equation. Therefore, plus pi by 2 means it is ahead of voltage. That means when voltage is 0, current is already it is in the peak value Im. So it comes like this. So this is the waveform of current. So the green one is I is equal to Im sine omega t plus pi by 2. So this is the current wave. And now what we have to do? We have to draw our phasor diagram. And as earlier we have drawn for both the circuits in the same way, take the phasor diagram like this. Already I told you, on x-axis we are taking omega t, that is the angle. On y-axis we are taking the values of voltage and current. Then already I told you in the previous videos also, take any point and select the values. So for example, take any value means here on this wave you can select any point of your choice like this and draw something like this. Let it be omega t1 at the time of t. Then what I told, draw straight lines from there. Straight lines means like this for your convenience. Wherever it touches the voltage and wherever it touches the current, draw some straight lines for your convenience in the beginning. All after practicing you will get it very easily. Now if you see, voltage makes an angle omega t1 with respect to x-axis. So voltage phasor you can draw in the same position like this always, that is making an angle omega t1 with respect to x-axis. Then what about the current? Current is ahead of voltage by 90 degrees. Ahead means it is going earlier, rotating anti-clockwise. So this will be the current, that is this will be the current. Exactly how much the size you have to take, or as you know, you have to extend these lines. Exactly at this particular point you can draw current. This is I phasor and this is the voltage phasor. Now angle between both of them is exactly 90 degrees, that is pi by 2. Okay, so now if you see here, this is voltage, that is in this particular situation we at omega t1. So you can take it as Vm sine omega t1. Similarly, and this one, the green color one which we have taken here, so this will become, I am drawing here, that is Im sine omega t1. So t1 plus pi by 2, sorry, plus pi by 2, because it is ahead of voltage by 90 degrees. With this I have also completed phasor diagram. All three diagrams are over. Last class also I told you the point about peak values of voltage and current. Vm is the peak value of voltage, whereas Im is equal to Vm divided by Xc. That is Im we are getting dividing Vm with some value, that is Xc. Therefore Im is always less than Vm. Therefore peak value of current is less than the peak value of voltage. With this I have completely done all the equations and also three diagrams. Okay, now let's go up and see one by one all the equations for a revision. Let's start with voltage equation. Yes, this is our circuit. The first equation is the voltage equation. which we got here, that is V is equal to Vm sine omega t. That's over. And the next one is current equation. Here we have our current equation, that is I is equal to Im sine omega t plus pi by 2. So here I have taken that as equation number 6. Then we need to know next, that is Xc, reactance. Here we have reactance. Xc is equal to 1 by omega c. And the next thing is phase difference between voltage and current. So here I wrote about that. Current is leading the voltage by pi by 2. Phase difference between both of them is pi by 2. That's also over. And the last one is power. Here we have the power. So power is equal to 0 in case of capacitive circuit. Then all the 3 diagrams are over. The first one is circuit diagram, which we have here on the top. And then next, wave diagram and the phasor diagram. Both are here. Okay. So with this we have completed all the details about AC through a capacitor. Thank you for watching. We will meet in the next video with LCR series circuit. Okay. That is the most important circuit. Thank you. God bless you all.